Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Welcome to another edition of the AI Innovation Space. We're glad to have you here. We have, our current guest, Zac Liu. Hey, Zac, how you doing?
I'm doing well. Thanks for having me here.
Yeah, and I also have my co-host here with me, Todd. Todd, how you doing today?
Doing well. Excited for this episode.
Excellent. So, Zach brings, some experience in the AI-driven satellite space, some work, building and deploying ML models, some work in the supply chain AI space with BrainChain AI, and we're really excited to deep dive into the conversation today. But I think we always like to sort of start with your background, sort of try to understand like basically your background, where how you got into this field, what you were doing before, and how you made that shift. So if you could explain that to us in a bit.
Yeah, definitely. So I actually got my degree in geophysics. I have the master degree and bachelor degree both in geophysics. So I'm not coming from a traditional computer science background. And for me, yeah, so I got my master degree in geophysics and planetary science. I used to study the surface of Mars and Saturn's moons called Titan. And yeah, I also studied Earth. I wrote some computer code and established some mathematical models to simulate tsunamis and also published some papers on those topics. I just want to say my most of my research was about building numerical models with data, which are mostly like remote sensing imagery and some observations or signal processing. It just my graduate work required me to do a lot of coding and also data processing, and I just developed a lot of those skill set. Which because I know how to code and how to like process the data and to make it ready to put into some numerical models. So it's not too hard for me to make the transition to data science in general. So how I got to AI machine learning is when I was in my PhD program, I learned about something called genetic algorithm and also learned about random forest. I just really fascinated by those techniques. So it was about 2014 and 2015 of the time. And I read about Harvard Business Review on data scientists and say, okay, data scientist is the sexiest job of the 21st century. So I just, decide to make the career move to data science. Yeah, because I was a bit kind of struggling with in the PhD program. I just don't understand why we have to write a lot of proposals to get the research funding. And I heard from the industrial side, you can get a lot of funding to do some work. That's how I kind of make the transition from geophysics to data science and machine learning.
I see. Excellent. So, Zach, since you come from a geological sciences background, I'm kind of curious, what are some problems that you think that machine learning and artificial intelligence could really help solve?
Yeah. So in those areas, I would say in the scientific community, how they kind of see machine learning I would say a lot of people still don't kind of trust machine learning technique, because if you use a neural network and to make some prediction, in general, the scientific community, they kind of don't want to use black box model, because in scientific community, the interpretability of your research is really important. So if you can really explain what's going on in the model, that's why people kind of don't use that. But I would say that people like they got really creative on that. For example, one area has become more popular, like in the geophysical research. So in geophysics, normally people will collect some data, some observation from a geophysical phenomena, and they will try to understand the data, and they will build a numerical equation and to represent those data they have observed. But in some geophysical phenomena would not be able to explain by just one or two mathematical equation, and a lot of those kind of some noise and some errors and come from those equation, because the data set you collected, you actually have some noises. So scientists actually got more creative and to use machine learning. Actually, they to use machine learning to replace those numerical equations. Just in general, in math, you have y equals to function of x, right? So most people will collect the data and the observation will be the x, and we want to put x into the function, and the function you produce the y, which is your results. And if you do the other way around, you actually got the some results like a y. You want to inversely to estimate the observation, and you can also plug in the y, and then you know the function, which is the mathematical equation, and you get x. And so machine learning, it's actually it's not dealing with x and y. It actually try to approximate like the function itself. So I noticed a lot of papers published about that is they replace those mathematical equation with machine learning model. And actually that works better because you are not limited to a specific kind of parameter in your equation, and you try to solve. And for if you have a lot of data, and then you can actually build a model to represent to approximate a geophysical phenomena, that actually works a lot better than traditional way. Yeah, hopefully that makes sense, because it's a bit complicated. I try to explain that in the audio only podcast.
I see. Thanks for sharing. So, when you talk about collecting geophysical data, what are some examples of that? And is that, to your knowledge, data that you can find like readily on the internet if you wanted to build your own model, or is it something that you have to go out in the field and measure?
Yeah, so a lot of those you have to go to the field and measure those. But just one example, I have done some earthquake, tsunami simulation, and observation. It just we have some sensors on the ground, and you use those sensors to collect the data. And for the tsunami, you also have some gauge station like along the coast, and so you can measure like the sea level when the tsunami hit, and how high was the wave. Yeah, so for a lot of those, I would say it's pretty expensive to collect those data set, because those has to be measured from some kind of equipment or sensors. And it's even more expensive you have some work with some planetary data. For example, on Mars, you actually need to send a spacecraft into Mars and to collect the data for you. And those also, yeah, it's even more expensive. You have to build a spacecraft. You have to build the instrument, and so you can send it to Mars. You have to wait for a few years, and just to get wait for the spacecraft to get there.
I see. So I think that's a good segue into another question I have for you, which is the work that you did with Hypergiant and AI driven satellite and space mission control. Can you kind of expand on what you guys were interested in doing and how that went?
Yeah, I can definitely talk about that. I just maybe I will describe the business problem first, and then I can dig into how we think about that problem and how we build a machine learning approach to solve that. So the business problem is like this: we currently have a lot of satellite in orbit around Earth right now, And when a satellite pass by a ground station, so we normally have about, I would say, 8 to 10 minutes of the communication window. And so we have some satellite operator, like they are working at the ground station, and they need to use that short time window and to communicate with the satellite. So either they maybe want to upload some data to the satellite, maybe they want to download some data, and so that's something we call uplink and downlink. So those tasks, they are kind of time sensitive. They have to be performed within a short time window, and so it's really critical. You need to have a really accurate prediction of those time window. So the operator at the ground station, they can kind of better prepared to handle those tasks. So currently, the state of the art model, it's called SGP4. It's a physics-based model, and it can only provide some reliable prediction about 12 hours in advance, which means a satellite operator know, okay, I got to monitor or I need to download some data from a specific satellite, and I would know the satellite will come about maybe tomorrow at 12 at noon, and that's the SGP4 told me. That a satellite would pass through the ground station. I have maybe 10 minutes time window I can communicate with this specific satellite. And so the issue is because SGP4 is a physics-based model, it got some errors. And so the prediction normally could be like 1 to 3 kilometers off, which you transition into time will be 2 to 4 minutes. Yeah, so I would say the operator would become some stressful if the prediction is not accurate, and they have to work with the shortened time window. So if you have, okay, let's say the satellite will come like around 12 p.m. and it actually came like 12:04, and yeah, so the operator yeah need to wait about that, wait for that, and also they have to finish the work because they one operator would need to take care of more than one satellite. I would say maybe some of them need to take care of over 100. And so if one satellite got delayed and because the prediction was not accurate, it will impact their ongoing work. So that's how we a lot of research has been going into this to solve, also to improve the SGP4 model, so we can have a better prediction for that. And also right now, the more reliable prediction is about 12 hours ahead, and we want to kind of, if we can make a really good prediction up to maybe 7 to 30 days. I think that would be more ideal because the satellite operator can plan the work just about a week ahead, not just 1 day ahead. So that's in general, that's a business problem. And how we think about this is we've seen a lot of research on this, and so at Hypergiant, we actually have some clients. They in the space industry, and they're kind of struggling with this problem. And we just form a data science team. We try to solve this problem. And the way we try to solve this, we've been seeing a lot of research papers talking about, okay, we want to improve the SGP for itself. And it's really hard to improve those because the SGP4, it's the state of the art. It's for about 30 years in the space industry. Everyone is using that. But as no one really can find a way to improve the algorithm by itself. And we know that, and we also tried that ourselves, and we eventually cannot build a new model actually can outperform SGP4. So we end up doing is we actually don't want to improve the model itself, but based on my experiences, like in the academia, is sometimes I would say so for this problem, because SGP4 is a physics-based model, and there are many other factors will affect the orbit, such as like some air frictions and air drag. Sometimes you have the solar wind and different particles in space, you so those physics-based model does not consider. And those we can consider those kind of noises in the data, maybe some errors in the models as well. And we have some data around that, and so we can use machine learning to simulate the errors. So we are not actually model, I mean, to improve the SGP4 model itself, but we actually use machine learning to machine learning model to represent those errors, just some factors the physics-based model does not consider. Um, yeah, so that's kind of the general idea of how we do it. We just tackle from another angle, and actually it works out for us. If you want to, I can go into more details about what kind of model we build, and if you are interested.
Sure, you can expand a bit. That was interesting to hear.
Right. Okay. The model we built also pretty interesting, and we built autoencoder. Um, we use autoencoder so we can reduce the dimensionality of our data, and then we convert the data into embeddings, and then build another machine learning estimator. We just use random forest. So we can predict the next time step of the encoded values. And then we once we have the random forest to predict the encoded value, and then we decode that and back to the same format as the observation. So it's pretty similar to the current kind of large language model stuff. We use a lot of embeddings, and then we do the semantic search and to search for the closest turn in the embedding. So yeah, actually, it's really similar. We did this work back in 2020 at the time, and yeah, we just use embeddings to do that. And the reason this approach work is the orbit. In general, it would repeat it itself in a regular time frame because it just orbit around the Earth. Yeah, so a lot of path they will repeat itself. So that's why it kind of worked really well for us because of the orbit nature. It just yeah, it's really suitable for this use case. And so eventually our model would kind of improve the SGP4 because we predict the errors are really good, and then you just use that errors and to make the correction to the original SGP4 prediction, and then it turned out we can actually predict a better like 20 to 30% better than the SGP4 model, which means yeah, the we also can do not only 12 hours in advance. We the model it's good enough to predict up to 7 days, and some in some cases you can do up to 30 days as well. So our model can give satellite operator more time to prepare and more time to plan and to do mission space mission planning and control. So that's how we get it. And I also want to talk about this because machine learning, you always say, okay, we have some advantage from this type of approach, but there are also some limitations too. So in this project, we also see some limitation because we need to have some historical data, and so the model can learn from. So if you, for example, a SpaceX launching like the new satellite really consistently like throughout the year. So if you have the new satellite in the space and it does not have enough kind of history and the coder can learn from, and that yeah we so the model will not be able to do well. And so that's kind of the limitations. But yeah, there's some other way you can overcome that limitation, such as we can build some synthetic data set. We can find, so for this new satellite, maybe just launched a couple of days ago, and we can find another satellite which is maybe a similar size and also in a similar orbit. And we can use that satellite and to generate some synthetic data. And so we can use those synthetic data to train the autoencoder and to learn about and to make the prediction for this new satellite. So that's another thing can we can overcome that limitation. Yeah, so that's pretty much about it. So I would say the most uh, research focus to improving this SGP4. I would say they are more kind of model centric approach. They try to trick the model and to make it better, but we come from a more data centric way. We actually work with the data and like look at the errors, and then yeah, so we try to improve that. So I would say we approach with a more data centric method.
All right, excellent. I really appreciate you sharing and providing your insights and the interesting topic. Any questions you have on any of that, Yanu?
Yeah, so I have a few questions around like what sensors did you guys use for those projects? What was the sensor data collecting? What are some of the details that you can share around that?
Mhm. Right, definitely. For in terms of data collection, the data for SGP4 is something called TLE. It's a two element. Yeah, it's a two element line like for a satellite. So the two element, the TLE data, it's about the description of the satellite orbit, such as coefficient of drag, and a lot of different parameters to describe the orbit. And so right now, there's a lot of organizations. They are tracking the satellite like in orbit every day, and then provide the database and to do that. So we actually query the data from a website called Space Track. And Space Track, they also provide a really easy to use API for us to get the data from them. Yeah, and how they kind of measure those the orbit parameters. I think they have different approach to do that. Some of them they have the telescope and to look for a certain satellite and then can measure that from there. So I don't know a lot of details about those, but yeah, there are many organizations are tracking all the satellite in space right now, and from their equipment. And their way the some of the sensors they have, they'll be able to track all those orbital parameters, and we just utilize the database we have right now.
Awesome. Thank you so much. I appreciate that.
Let's talk a little bit about your current role at BrainChain AI. I know you can't go into too many details, but just kind of curious if you can give us kind of the business case and what you guys are trying to use and how you're using AI.
Hmm. Right. So right now I'm the founding machine learning engineers at BrainChain AI. I joined the team about 2 months ago, and this is the new team we are building. We try to automate some of the business process in supply chain. And so the first thing we are doing right now is we are building some AI and machine learning technology, so we can detect to find the signals of the potential supply chain disruption, like around the world, and we are not limited just to the US, but also anything around the world. And how we do that is we kind of source everything from the internet. And so, for example, we scrape the news, and we also try to scrape some social media as well, and just want to understand what's going on in the world. And for example, we also use some generative AI approach, and such as large language model, for us to digest the news, and then we can know some potential shortage in supply chain. For example, our model currently, for example, we can detect some signals about the egg shortage and happening in the U.S. I would say it happened a few months ago, and so our model can look for those type of signals. And so, yeah, our business model is more like we want to detect those a shortage, and then we have a business team, and they are well connected. So the machine learning model will identify like the shortage, the area, and then our business team would go kind of source those commodity or materials or some medical equipment, and they can source those products, and they can send it to the area who is in need of those products. And so we can make a little of the profit from that, and also to help and smooth the supply chain disruption. So that's in general like we are doing right now. And we have a really talented engineering team, and we just want to build use this new kind of model, such as a large language model, and for us to automate like discovery process.
I see. Thank you for sharing it. It sounds like that work really has potential to impact the lives of many people throughout the world, being able to predict these kind of disruptions as you're talking about it. What do you see as been some potential benefits, I guess, for society from this?
Yeah. I'm glad like you asked that question as well, because the company was actually founded during the COVID time, and our CEO and the founder of the company. And so during COVID time, he actually helped to smooth the supply chain disruption for the masks, and also a certain type of medical devices. And yeah, so I would say he helped a lot during those times, just to send the mask to the places who like in high demand and in shortage. And so actually that would save a lot of people's life as well, just to improve that situation. He was doing that a lot of business operation manually. So yeah, right now he just think, okay, we should have a better way to do this, and why not we just use the new technology like in AI and machine learning to help them to automate a lot of those process. And yeah, so I can definitely see this can potentially to help and to smooth the supply chain disruption around the world, because we don't actually don't want to wait on those products like kind of in shortage. For example, in California, also a few years ago, we had a really bad fires. And so still remember there's a time like around 1 to 2 months, and people try to buy the air filters for their homes because the air quality is so bad. And those air filters, they are in high demand, and we cannot get anywhere. And if you order from Amazon, you have to wait just over 1 or 2 months and to get for those to get here. It just, yeah, so if this approach work for that, and then the company can actually help and to smooth that disruption, and to get the commodity and also the products that people need in some areas. So I would say I really like this idea, and they can actually help the societies and different communities, and we can serve them better. um, yeah, I just really like this business ideas.
That's great. Yes, I know we both completely agree with what you're saying there and have great impact on people. So one other thing I was interested, I know you have some experience in machine learning operations, MLOps. Can you kind of speak to what you've done in that space, or any particular roles you might want to speak to?
Yeah, definitely. So for the machine learning operation, maybe I just talk a little bit about what is machine learning operation to begin with. So yeah, machine learning operation is called MLOps, and I would say it's an extension of DevOps in software engineering. And the difference between DevOps versus MLOps is machine learning is not only dealing with the code, but also you have to deal with the data as well, because the data is the core piece of the machine learning model. So MLOps is all about how you manage the machine learning lifecycle, such as people will build machine learning pipelines, and to help them to manage the training the model, and then deploy the model. And MLOps is also about how you scale your machine learning applications. So people nowadays utilize Kubernetes and to do that. and just to have some auto scaling capability. And if your machine learning application is in need of more resources in terms of the compute or memory, and so Kubernetes can help that for you. And another aspect is about like to monitor your machine learning system, and so you can monitor the performance of the model, and when you might have the data or model drift, and when you might want to retrain your model, and how much resources you need in terms of if you are doing the online inference or batch inference, and yeah, just to manage those machine learning process. And another aspect is about CI/CD, just to automate a lot of machine learning process, because you don't want to do each machine learning kind of step like by hand, like to do that manually, and you actually want to type like the whole machine learning workflow, you can to make it more autonomous. Yeah, so my experiences on those is actually I worked for Google before, and I was building something called Qflow. So Qflow is the machine learning orchestration system, and you can actually package your model and or one of the step in your machine learning process into a container, and you can orchestrate that in Kubernetes. And yeah, so I was when I was working at Google, I was building that Kubeflow, building specific for computer vision Kubeflow pipeline component. And then because I have some experiences on that, and so back in the days in Hypergiant, we actually have some ideas. We want to build a machine learning platform, because nowadays data scientists, people already talking about data scientists. It's like they need to know a lot of things, and such as they need to know the business problem they want to solve, and they need to know how to code, and they need to understand like the theory of machine learning, and they have to do make a really accurate prediction for the business. So they have a lot of things to do, but because machine learning like MLOps is so new, and it has been like the new tooling come out every day, so they have to learn all those as well. And a lot of data scientists like myself, we are not coming from a traditional computer science background, so a lot of software engineering practice we actually don't know. We don't know how to use Docker, for example, to containerize your machine learning model and artifacts. And so we just feel like so it's really hard for data scientists to keep up with everything. And their the core value a data scientist can provide is actually the business value. So we don't want them to spend too much time to figure out how to deploy the model, how to uh, automate all those engineering process. So that's why, yeah, we built a machine learning platform like in Hypergiant to begin with, and then we spin off that platform team to a separate company called Andromeda 360. And so in Andromeda 360, we build yeah, the machine learning platform. So the goal for that ML platform is to abstract a lot of machine learning infrastructure complexity from data scientists, and so they can focus on providing the core value to the business. They can work on the data, and they can build a model without worrying about how I going to scale my machine learning model in production. So we handle that for them, and we also design a really simple to use UI. And so once a data scientist finish training the model, they want to deploy it, and we provide the UI for them just to have the few click, and they actually after the few click, the model can be deployed into a Kubernetes and will become a cloud endpoint API, and so their model can be in production. We also provide some monitoring dashboard, and so once the model in production, its job is not done yet, and so they have still need to monitor the model performance, and we have some dashboard designed to help them to identify a potential data drift. And also send some alert to data scientists so they can know, okay, so now is the time we need to retrain the model. So we also provide some functionality for them to retrain the model, and also to version the different version of the model, such as, okay, so this is the version number 2 and retrained by what day. Yeah, so we provide design like the whole kind of platform, and just to help them to data scientists so they can do focus on their work. And so that's pretty much about kind of my experiences with that. So in Andromeda 360, we built a product called A360 AI platform. And in MLOps, I would say currently it's really crowded. It's a lot of different startup. They're also doing the same thing, like what we did, and also the big cloud providers such as Google and Amazon. So Amazon has the SageMaker, can do similar thing, and GCP also have Vertex AI also to do the same thing as well. So and Andromeda 360 with, yeah, trying to compete with the big cloud providers, and as well as some startup as well, like such as for example, the Snorkel AI. They are also doing the same thing. They are building a machine learning platform, but they are more focused on the data annotation part. And another player such as Databricks, they also have provide their own version of the ML platform, and you can also deploy the model within a few minutes, like you can do with our platform. Yeah, so right now the ML ops space is really dynamic, and also it's, I would say it's a super crowded at this point. And because those solution, I would say it's not really hard to build if you have a capable engineering team who understands software engineering and also who understand machine learning. And so each team can actually build their own internal tooling. um, so that's another reason. I recently worked with a company, a startup called Self AI, and so we are thinking about the same thing. Like over there in the team, is it's really critical for a machine learning team. They can control their own kind of tech stack. So we have a group of people who have similar. Um, I would say we have the similar idea. It just to use. It's kind of turned down to the question. It's you want to build your own, and you want to buy a vendor's solution for your team. And so a lot of engineering team I have spoken with, and a lot of them, they actually prefer to build their own, because they have full transparency in their production system. They can have the full control, versus working with the vendors, and vendors will manage the platform for them. But also there are some limitations over there as well. So yeah, I can go into more details, but just want to see if you have some questions around this topic.
I mean, that's really interesting to hear your perspective on machine learning operations. I definitely see a lot of value for organizations that use that. And as you said, there's a lot, it's very crowded right now. So it'll be interesting to see how that space develops in the upcoming years. And another thing we're really interested to hear, Zach, is about your interest and your experience as a machine learning research associate with Stanford University and the D. Leo Lab for the Marine Station. Can you expand on how you got started with that and what you've been involved with and over the years?
Yeah, right. At Stanford, actually, when I was trying to kind of break into this data science, around also 2015 of the time, it's, yeah, I first to work with Stanford with the Hopkins Marine Station, because I live in Monterey, California. And so Monterey Bay Aquarium, as well as Hopkins Marine Station of Stanford, it's both kind of located really close in Monterey. And that's how I got it to kind of to use machine learning to solve some scientific research problem in biology, and also in marine biology. So that's how I got started around that time. And so a lot of projects I've been involved throughout the years, but in the beginning I kind of served more like a machine learning researcher, just to work with different PhD students and also research technician to utilize machine learning model to solve some research problem. And nowadays, so because after that, I got some full-time position at the industry, and but I still kind of keep closely to working with the lab, with the Leo lab, to work there part time. I still part time engage, and nowadays I'm more kind of in to help mentor the PhD students or maybe some postdoc if some team lab members they want to use machine learning to solve their research problem, and they will come to me and I would try to help them and to provide the guidance and different suggestions and how they can use to utilize their data and to build a model around that. And yeah, so right now I kind of just advising a little bit and also do a little bit of the work. But throughout the years, I've been involved in a few different interesting research problem, and like including the white sharks. And so most work around white shark, that's I did it with Monterey Bay Aquarium, and the some in for the DLEO lab at Stanford University, I deal with more in terms of the images, like in computer vision, such as the parasite and snail image classification, and some satellite imagery, the computer vision for that, just to predict the carbon stock in tropical forest. With a deep learning approach. Yeah, I can speak of any of them. If you, do you have any preference?
Yeah, so the carbon stock that you guys were monitoring in the forest, you said you were using satellite imagery for that. Can you expand on that topic?
Yeah. So right now, for that project, and because we were working with a nonprofit organization called Health in Harmony, and they work in Borneo, Indonesia. So they have some research done in that area. And something we are looking to is because there are some deforestation happening there, and they try to improve that situation in Borneo. Because the tropical forest is the key kind of to observe the carbon like on Earth. So the forest is really important to keep that, and also to estimate the carbon in forests. It's really kind of expensive to do, and right now you have to send a team of the scientists. They have to go down to the field and to the forest. They have to measure like the tree, the thickness of the tree, and also they need to estimate the tree height, and so they can get a sense of how much carbon stored in that specific tree, and then they can use some estimation and to expand to the whole forest. And so it's really hard to do, like just to send people on the ground to do all those measurements. So luckily, like because of the technology advancement, like in space industry, nowadays you can send the satellite to space, and you would take some satellite imagery, and then you can use those imagery and you can infer, for example, the tree height, um, and you can also infer some properties of the forest. Yeah, so we use the satellite imagery, and also we combine with some lidar data. So lidar, it's a more like a laser, like from a satellite, and it can pretty accurately to estimate the tree height. So our approach is actually to use the satellite imagery, and then we also have some lidar data, and so we know the tree height, and there are a lot of research around if you know a tree height, and you can use that tree height to put into empirical equation to get the carbon stock estimation. Yeah, so our goal for that project is just we use the satellite imagery, and also we have the lidar data, and our goal is actually to build a model to predict the carbon stock directly from the satellite imagery. Yeah, so we can kind of monitor the deforestation in any forest on Earth, just to monitor that, and also to estimate the carbon stock as well. So we can kind of see the time series change around the carbon stock, and how well we are doing to preserve those forests. And if we have a lot of deforestation in a certain area, and then we need to have some action and can be taken just to help to prevent the deforestation.
Excellent. Thank you for sharing. That's a really interesting topic that has a lot of potential to help
Hmm.
understand this problem. I'm also really interested to hear some of these marine biology examples that you were working with Stanford. Can you expand a little bit, maybe on the snail and parasite image classification problems and some of the work you did with sharks?
Oh yeah, with the sharks. Yeah. So there are two major projects I did in that area. So one is called the prediction of the shark locomotor activity. And this is the term in biology. Essentially, it means we want to understand the calorie consumption of the shark. So just the energy consumption. You just imagine that we try to measure how much calories a shark has burned during a time frame. So that's something we try to figure out. And so that's really interesting problem for that. It's a perfect kind of example how scientific community can utilize machine learning to help with their research. So in the shark research community, and so right now, how they monitor like the shark movement is they will put a tag on the shark. Either they can clip on shark fin, or they can clip one in their on their tail. And so those and tags, they are sensors, and it will measure how deep the shark would dive, and also what's the movement around that. So they have two type of tags. So one tag, actually, it's low energy, and so the battery over there can last maybe up to a half year to a year. So if you put the tag on the shark, and then because it's kind of low energy and it's only measure a few things, so the battery can last really long, just maybe up to a year, and you can collect those data for about 1 year for the shark's movement. And there's also another more kind of energy consumption tag, and it measures more. Actually measures more kind of movement from the shark, and that's something scientists are more interesting into that type of data. But the downside of that tag is the battery life really short. Maybe it's around 2 to 4 weeks only, and because it measured so much more information for a shark. And so there are some limitation in terms of the hardware, and so one tag it can record a really long period of time, but it's only record for example the depths of the sharks diving. And another tag actually measures what scientists are interested, and it's more useful for the research. But that tag just can only last for about 2 to 4 weeks. That's how we use machine learning to kind of augment the gaps between these two types of data. So the approach we kind of did, the model we develop, we actually look at this two data set, and then we build a model from like one tag which only have to measure the depths of the dive. And then so the model can take that data and make the prediction for the calorie consumption of the shark, which is the scientists are more interesting in that data. So you build a model around that, just from the low kind of resolution data and to predict the high resolution data. And actually it works really well. So the idea is once we have this model, and so the model actually was built and it got a really good R square. I would say it's around point 0.8 to point 0.9. And then so the hardware engineers, they can go back to kind of change their design. So the idea is so if that high energy kind of consumption tag can only last 2 to 4 weeks, but we can design a mechanism by putting in place for that tag, and it can only just need to turn on maybe for a couple hours, just to collect those really high density data, and then it would turn off also for a couple hours and just turn on and turn off, and so it does not kind of always on that for 4 weeks. And so if we do that, it can last over maybe half year. And then so because the tag was turned on and turned off and just after a few hours, and then we use this machine learning model and to fill the gaps of those data. And so this way scientists will have the calorie or energy cost of the shark for over a year. So that's our goal because it's never been done before, and it's really hard to collect a certain like kind of shark activity for about a year. So we all can only get a couple weeks of the data, but with this approach and with machine learning to fill those data gaps, we can actually collect the full kind of shark activity up to a year, which had never been done before. And because we have those data for about a year, and we would kind of know what sharks are doing during that year, and it can provide kind of open a new door for the new kind of research, and so we understand more about sharks.
I see. Excellent. Thank you for sharing. Really interesting how these machine learning projects can be worked in the scientific community like you're doing with Stanford.
Yeah, yeah. So that one is a really interesting project, just to understand like more for marine conversation, conservation, and because yeah, people got a lot of kind of misconcept about the shark. They think, oh, they are kind of dangerous and they attack people, but actually it happened really rare. And to able to kind of preserve those amazing animals in the ocean. And yeah, the scientists just need to find a new way and to understand them. And machine learning can help with that, just to help one of the piece and of the mystery. So that's one project. There's another project also pretty interesting. I can share that a little bit. It's about a shark fin detector. So because a scientist, they want to monitor a different individual of the shark, and then how people tell apart like from, okay, so this is a shark number one, this is shark number two. It's actually based on the fin of the shark. So the fin pattern, it's unique for individual sharks. It's like our fingerprint. So shark fin is the fingerprint of the shark. So you can use that specific fin pattern. You tell, okay, though this is this individual. And so in Monterey Aquarium, so they are tracking about 500 white sharks around the world. And so those 500 sharks, they're in their database. And so one issue they have is they get so many individuals that they want to track, and so each year they have to go to the ocean, like have some field trip just to go to the ocean, and also to uh, they would bring some equipment, and they want to take the picture of the shark. They also taking some underwater videos as well, and so they will get on the boat and just to yeah, use some underwater camera, and they would search for the shark. And when they find one, and they would just try to take a lot of pictures and also the video. And the video normally they focus on to take the shot around the thing, because the thing is to help them to identify which individual they are tracking. Yeah, because there are so many different sharks, and also in the field, it's just really hard for them to recognize each shark in the field. So something will be helpful is they can collect the enough shark fin images, and they can develop the image classifier. And so once they have take one picture of the fin of the shark in the field, and maybe they just upload that picture to the app, and that application would tell them, okay, so you are tracking shark number 5 in the database right now. So that would be super helpful for the scientists. So that's something we were trying to build. Is we have want to be build a shark fin detector for people in the field, and also when they collect a lot of data in, so they can bring those back to the lab, and they can identify to match those data to their database. Because the shark fin, you have to take a really close and detailed of the picture. It's really hard. You can really kind of capture shark just to take a good picture around that. You have to kind of work around them. So they have a lot of underwater videos. And what I did is I developed kind of the pipeline, a machine learning pipeline. So it would take a video, of underwater video, and we have a object detection model running on the background. So it would draw a bounding box around the shark fin in the underwater video, and then the algorithm would just automatically capture the shark fin in the bounding box, and then it crop the bounding box out, and then put into another machine learning model just to filter if this bounding box of the shark fin is that detailed enough, and if it's a good quality. And then if it is, it would send into and stored in a specific place in our database. And yeah, so just that model, we would just draw a bounding box and then capture that and save to our database. And then we have another image classifier just to retrain on those images. And so eventually the model can classify like 500 individual sharks. And so before I did the project, I think we were able to classify maybe up to 20. But yeah, I think they can do more right now, since we have the pipeline setting up. It's up and running all the time, just to collect and to collect those images, and we have more data at this point.
All right, excellent. Thanks for sharing. It was interesting to hear about those machine learning projects you worked on with sharks. One final question I have for today is if there's any challenges that you faced in machine learning that you would think would be relevant for our audience to learn more about, and any applications that you kind of feel, maybe even the scientific community, because you have some scientific background, you think AI or machine learning might be beneficial for in the future that's kind of not really being looked at right now.
Yeah, there are a couple of things I can share. I would say the first one would be the current new development in the large language model (LLM) and the generative AI, and those type of autonomous agent to many business problem. They haven't actually used those technique yet, so I would say it's more like an unexplored territory right now for a lot of different business. So I would say because there's a lot of business use case has not been explored by utilizing those applied to those large language model yet. It just, for example, one use case would be if you want to do the video classification. So traditionally, you will have to collect the videos, and you have to train a deep learning model. You have to kind of do process the data as a training set and test set. And if you want to do video classification, say, okay, so this is about you have 10 topics, and you want the model to classify. And you might, yeah, have you need to collect a good enough data, and for each image it's really expensive. You have to train the model and use GPU to do everything. And so that use case could be improved by a large language model. And so you can pretty much use OpenAI's on GPT 3.5 Turbo, or just the ChatGPT model, or you can use a GPT-4 model just to do that. You actually can just you don't have to train your own model. You just use a large language model, and just to give a correct a right prompt, and just to tell the language model, say, okay, so this is the audio of that video, and by reading like the transcribe of this video, just tell me about the topic. And then you don't need to kind of train any deep learning model for the video. Yeah, just for that. So just one simple use case, and kind of people can think of, just to use a large language model to do a lot of heavy lifting for them. So I would say this new kind of advancement in the language model in general will also change a lot of work we have done as a machine learning engineers or data scientists. If you know the limitations of those large language model, and what you can get out of it, and you can actually find a really creative use case around that. Yeah, so it's one specific kind of area I want to talk about, just to, yeah, to always use the large language model, and to see how it can do for you. So I would say oftentimes it can surprise you, and actually in some use cases that can actually work really well. And I envision like we can see more on this type of use case come out going forward. And in terms of for the scientific application, I also want to kind of yeah, let the audience know for in the scientific community, you can also get creative in how you deal with the data. You can use machine learning model and to help you with the data processing as well, just to fill the gaps of the data. And you can build a machine learning model to approximate those mathematical equations that you have built in the research, because we are not using machine learning as the black box. So which a lot of people kind of in the scientific community, they oppose that. But to how to utilize like machine learning kind of strength from machine learning, you just, yeah, for example, just something I did before is to use the model to approximate like those equations. You can use the model to kind of to augment the data, and you can get more kind of synthetic data set as well. And so those, you kind of utilize those strength of the machine learning model, but also you avoid those kind of black box interpretability. So that's one thing I also suggest.
Yeah, sorry, I had a question for you. So, basically with the large language models, right? Um, it's very easy for people to try to use maybe something like a chat GPT or OpenAI, or leverage a tool or its APIs to do, more creative things and things like that. Do you think that, we've hit, the peak on that, or do you see, a drill down into very, very unique applications of these large, language models? How do you see that spectrum, becoming?
I would say for this, for right now, um, maybe that's the approach I would recommend. It's so in any use case you're thinking to use a large language model, the first start we can just utilize OpenAI's API, and just to try if that work. And because you are sending like the data into OpenAI, right? So because of data privacy and also some competitive advantage, you want to keep the data yourself. So you probably don't want to send everything to OpenAI. And so at that point, you just, first is to try OpenAI to see if that might work. If it that work, and then great. The next step is to kind of train your own large language model with some open source and solution, and then you train a more specialized language model for your own use case. So I would
I
say,
see.
yeah. So the first is just to use the general model and to test it, and then eventually you want to train. You want to build your own specialized model for your own use case. So I would say the large kind of language model will still exist, and they are still really good to use. But then eventually each company will have their own kind of a specialized language model for their own use case, and
That
some
makes sense.
on open source as well. So I
That
was
makes sense.
area. I mean, this area will be really exciting for the next couple of months and over the years as well, because as more innovations come out with those as specialized model.
Thank you.
All right, excellent. Thank you, Zach. We really appreciate your insights. Really, I feel like we're in an exciting time here with AI, and a lot of the work you've been doing has a real potential to make a positive impact on society and life in the world.
Yeah, I agree. Like, it's a exciting time to be in this space, and more people will come into this space as well, just to learn about the new technology. And this new technology can actually help people and also improve people's life. I think that also is a good aspect of this.
I agree. So we would wrap up, here, but like Todd said, we really want to appreciate you coming in. Really great conversation on basically from sharks to carbon and to shark fins. It's just been super amazing. I have lots and lots of other questions for you that I would have loved to be able to ask. Hopefully we have you back, sometime soon to share in more details with us.
Yeah, definitely. Once we have more development in BrainChain AI, yeah, we can share more on that.
Thank you all so much for joining another edition of the AI Innovation Space. We're glad you're able to join us today and looking forward to having you back on our next session.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.